So thank you very much to the organizers for inviting me here today. My name is Kris. I live in Sydney, despite the accent. I was here at Voxxed Days last year as an attendee, so it's really amazing to be back as a speaker. And I'm here today to be talking about building applications that stand the test of time. And I thought I would start out with a fun little trivia question for you. Does anyone in this room want to take a guess, just shout it out, what the oldest piece of software still being used in production is anywhere in the world right now? Anyone want to guess? Come on, no one?
30 years.
What do you think it is? Like where would it be being used?
Some really old corporate government.
You're not far off. When I posed this question to myself a few months back, and my guess was that it was probably something on board the Voyager spacecraft, the Voyager 1 and 2 satellites. So they were launched in 1977, both very similar. And the software on those has been updated in flight, but they've never been shut off completely or changed completely. Each one has just shy of 70 kilobytes of memory. The fun thing I found is like the scientific data that they collect is actually written to 8-track tape before it gets submitted back to Earth, and then the tape gets written over each time. It was originally written in Fortran 5, and some of the software is still in Fortran, although other pieces have been ported to C, the more modern C. But the real answer, and someone was on the right track, is MOCAS, M-O-C-A-S, which is the Mechanization of Contract Administration Services. This software was launched in 1958 by the US Department of Defense for keeping track of contracts and payments. So MOCAS turns 60 years old this year, and they are not looking to retire at any time soon. Current system is still managing $1.3 trillion in obligations, 340,000 contracts on an IBM mainframe, a IBM 2098 model E10 mainframe with a modest 8 gigabytes of RAM. This application was written in COBOL before the COBOL spec was approved. The original interface used punch cards and key cards, though nowadays it was then later updated to green screens, and now you can even integrate it with on your desktop PC and use it with Microsoft Office, which I thought was really cool. Some of the other ones people have suggested to me are some of the open source software you may have used. So for example, Linux only dates back to the 90s, so 1991 for Linux and Python actually. Perl goes back to 1987. Emacs, 1984. Anybody using Emacs? That's a pretty old one. And Unix itself was 1969, so MOCAS predates all of that stuff. I did find some mention online about this water filtration company called Sparkler Filters that claimed to still be using a punch card system to manage their inventory from 1948. But the last news story I could find about it on the internet, they talked about the fact that they were finally looking to upgrade that sucker. So I can't verify. They would be the oldest if that's the case. So is anyone here running any code or running an application that they built prior to, say, the year 2000? No, no one. Well, I am. I have a website dedicated to the famous English author Roald Dahl. Have any of you ever heard of him? Yeah. He wrote a bunch of children's stories that you may have heard of. You know, James and the Giant Peach, Charlie and the Chocolate Factory, the BFG. He also wrote a lot of short stories for grown-ups. And so I have a website for him called RoaldDahlFans.com. This is what it looks like. It's got information on all the books and stories he ever wrote, movies, TV shows. It's got lesson plans for teachers and trivia quizzes for kids and events around the world. But the really important bit is if you scroll all the way down to the very bottom and you see the copyright. This site has now been running for 22 years. I built it in uni and it is still going. How many of you were even on the internet in 1996? Much less building websites? Yes. This site predates Google. Google was founded in 1998, children. Okay? So I thought that I would tell you the story of my website, how it evolved along the years, what I learned along the way, why I think that building software that lasts is really underrated and valuable and important. And then I'm going to talk about some of the techniques you can use to extend the life of your own applications. But first, a warning. I was never a designer. And friends, the early 90s on the web was a different place. Okay? It was a bit rougher around the edges, so you're going to see some stuff, all right? So as everybody brace themselves for the first screenshot, here we go. Boom. This was 1996. This is what the site, this is the earliest version I could find on archive.org, I should actually clarify. Yay, yes, this is what the internet looked like back then. So I was a second year at university. I was actually studying film and theater randomly, but I'd fallen in love with this thing called the World Wide Web and building websites and learning HTML, and I knew that I wanted to be a part of that. So I made a sort of really crappy personal site, you know, as everybody does. And then I thought, oh, my favorite author as a kid, there's no web page for him on the internet, so I'll build one. I can make one, right? It lived at the very memorable URL nd.edu/khoward1/roald.html. Yeah, really good. And this is what websites looked like back then, you know. It was system fonts, it was tables for layout, liberal use of the center tag. And the site back then was only a few pages, so my navigation was just text links. The heart of the site, as I called it, was the doll catalog, which is where I started collecting links off the internet. I started writing reviews of his stories. I started scanning in book covers. And the really great thing is that I had validation of my idea early on. It got written up in like an early issue of like Hotwired or something, and I had teachers finding it through that and emailing me. And then they started sharing me their materials. So there is the, I think I can do this, BFG for President down there at the bottom, which was a lesson plan that a teacher used and sent to be shared on the site. So it was really great to have that early confirmation that people were finding this site useful. So this is where it started, and I eventually then decided that this is where I wanted to make my living. So over the years, as the site evolved and as I gained new skills as a developer, the site changed along with it. So in 1997, I learned to use Photoshop. I made myself some nifty buttons for navigation. You see the site is growing by this time. And look, I didn't know the term information architecture. That was not in my vocabulary, but I started feeling my way around it. I started trying to figure out how I was going to make sense of this growing pile of information. So this is sort of my first early efforts there. 2 years in, I did my first major site redesign, and yes, Comic Sans, just suck it up because you're going to see a fair bit of it, okay? In my defense, a lot of the visitors to the site were children. So other things to note here, look, my site structure has grown some more. I've got now 3 different sections. I had also learned the super high-tech trick of image maps. Who remembers image maps? Yes, they were great. You would define coordinates on an image, and then they would become hyperlinks when you moused over them. That was just the coolest thing ever. Web rings were stumble upon before stumble upon existed. That was how we discovered stuff back then. What else? Okay, 3 years in, I added a splash page because for some reason, we all thought that the internet needed a front door for every website. And I also learned how to make animated GIFs, obviously. This was really cutting edge stuff. And you'll note here, totes professional, I finally moved to my own domain name, roalddahl.org, because I had graduated from uni and I was now a professional working web developer in London. This is what the site looked like back then, entirely hand-coded, pretty much in Notepad or Alair home site. I was a big fan of home site back in the day. The navigation has again expanded from 3 sections to 4, including the excellently named miscellaneous section. I apologize to any UX professionals in the room. Like I said, not a designer. The site is now fixed width, you'll note, in a big old table constrained with a center tag right down the middle. And if you scrolled down even further, you would see I had a listbot mailing list. RSS didn't actually exist back then, and so this was a way that I could alert folks when I updated the site. I literally would send them an email and say, hey, I added some stuff to the website. Since I was now paying for a domain name and hosting myself, I gave in finally and monetized. I became an Amazon affiliate. I've been probably one of their oldest ones still going. So you can buy his books and I get a little bit through that. Check out the AOL remote. Remember that? That was really cool. It allowed you to send me an instant message. This was really, really high tech back in the day. So I was a front-end developer right now, and I was learning JavaScript and using that in my day job. So I immediately thought of a really great way I could use that on the site, which was trivia quizzes. So each question had a correct answer, and it would keep track of how many you got as you went along. Now, obviously, you know, it would take you 1 second to view source and actually cheat. But little kids didn't know that, and they loved this. So very quickly, I saw that this was a very popular part of the site, and I started creating a lot more quizzes. So let's finally jump into the new millennium. The biggest change here is I had another domain name change, so I finally got the dreaded email from the Roald Dahl people. And rather than shut me down, they were like, hey, this is awesome. We're finally building an official presence for him. Would you mind if we had the roalddoll.org domain? And of course, I gave it to them, and I switched to Roald Dahl Fans, which is what it's been ever since. But I also got to go to his house in England and meet Felicity Dahl, his widow, and tour his writing hut and the gypsy caravan. And this was just the pinnacle as far as like a Roald Dahl fan was concerned. I finally killed the Comic Sans. There was much rejoicing, except for the logo, because I kind of figured it was kind of my branding, you know. The navigation has expanded even further. We got 5 levels now. I added a blog via Blogger because it was kind of the law in the year 2000 that everyone had to have blogs. I used it to like keep track of the updates when I added updates to the site. Remarkably, I actually had site search back on the site back then using a third party called PicoSearch because Google were still in their infancy. They were not offering site search back in the year 2000. So I found this third party that would index your site and give you a form that you could actually embed to offer site search really easily. This is about when my love affair with the rounded corners and the spacer GIF really took flight. Like, I was a wizard with that stuff, you guys. And I know nowadays, look, you all know better than to use tables for layout. I know that, but this was the state of the art back then. I remember with my colleagues having long arguments about the latest WebMonkey article about the best way to nest your tables for optimization and speed, you know? And the really cool thing is this site, it looked the same everywhere and it ran everywhere. I remember in London, we even loaded it up on like a brand new web TV, which was this terrible thing they were pushing back then. And it worked and it looked fine. You know, you can't say that about a lot of sites that you build these days. Now this is around the time I moved to Australia and I started learning PHP. And I quickly realized, hey, I can use this to add even more functionality, to make my site more interactive. So I started refactoring it. I started pulling out components and making them database driven. The first thing I built was a system to run polls, just a really simple proof of concept. And hey, that works pretty good. Then I added a calendar to keep track of upcoming events. I, instead of using Blogger, rolled my own blog to keep track of the site updates. And the nav, you'll notice, is so big by this point that I've introduced a 2-column layout. Yes, still done with tables. Of course, the trivia quizzes were like the biggest benefit of moving to PHP because now you couldn't cheat anymore. And I had a genius idea that if you got all 10 questions right, you could put your name on a high score list. Little kids freaked out over this. They loved it. I would have entire classrooms of kids go into computer lab and do the quiz, and then I'd know because I'd get like 30 results all at once. The problem, of course, is that if you put up a wall, little kids will graffiti it. So I had to build like an admin area where I could go in and delete all the like Mr. Poos and like Mrs. Fart, you know, and all those names that they would put in. So this was the admin area that I built myself, as you can see, very rudimentary back then. Now look, I'm not going to show you 100 more screenshots. And honestly, the truth is there aren't that many more because after 5 years of doing this, like I was a grown-up. Like, this was a little niche thing I did in college to learn skills. Now I'm a professional web developer. I'm living in Australia, you know. I don't have time to work on this. So I really just sort of stopped. I kept it going. You know, every now and then I'd sort of feel guilty about it sitting there and people sending me emails. So I'd add a new feature. You know, one year I added greeting cards, like little Roald Dahl images you could email your friends, and that was when I learned to use, you know, email functions. I rolled my own search using htdig, which was an open source search engine software you could use. At some point I added Google AdSense ads, which are the only ads on the site, and that basically just pays for the hosting. I added an RSS feed at some point, which was pathetic because it just showed you how seldom I actually updated the thing. The real death knell was in 2008 because by then I'd sort of moved into more of a management role. I wasn't hands-on coding in my day job anymore. And that's about the time that blogs and those early websites, you guys know this, they started to dry up, you know, they started to die off. People started moving to social media and Facebook and Tumblr and stuff rather than building their own sites. So I was really just keeping it going out of stubbornness, you know, it paid for itself, there was no reason to take it down, the content was still good. I found this kid in the UK who was really excited, he helped me answer emails and I'd split the ad revenue with him. And so this is it this was 2015, it still looked like it did in 2001. This was just a few years ago. And I was cool with that, you know, it was just this curious relic from the early days of the internet, you know, like pulling up a coelacanth from the ocean. It's still useful, it was still going, didn't hurt me anything to leave it there. And then it got hacked. It got hacked hard. And I still don't know how it happened. I logged in, I FTP'd to the site one day to do something, and I saw this directory I didn't recognize. And when I clicked on it, it was full of Viagra ads and stuff like that, and my heart just sank. And I worked with my host, and I cleaned it up, and we sort of locked down some permissions. We thought maybe that was the culprit. And then it happened again a few months later. And I was just really heartbroken and just sort of angry and frustrated because I didn't know how to fix it. And ultimately, I was horrified because when I stepped back and looked at this beautiful little handcrafted gem that I thought I'd been so proud of all along, I realized just to my utter horror what it had become. It had become the dreaded legacy code base. And I'm guessing that every one of you in this room has inherited a legacy product at some time, whether or not you wrote it yourself. And you know that you've really only got two options at this point. You can rewrite it completely, start fresh, do things right this time. This is the burn it to the ground in a righteous cleansing fire option. And that is always the one that we want to do. That is always the first one we go for. Or your other alternative is incremental redevelopment. And I've used a sailboat emoji here. Does anyone know what the ship of Theseus is? You've heard of it. Yes, this is a famous philosophical thought experiment about the legendary Greek ship of the hero Theseus. And the idea is that they preserved this ship by every time a plank in the ship went rotten, they would replace that bit of wood. And eventually, over time, every single bit of the ship had been replaced. So is it the same ship? And this is what I mean by incremental redevelopment. You refactor and you improve it and refactor it just bit by bit. But I know you don't want to do that. I don't want to do that. What we want to do is hit the big red shiny reset button. That's always the impulse. It is so tempting. And there's so many reasons we tell ourselves that sound so logical. The code is a mess, right? It's poorly architected. It's really hard for new people on the team to understand. We got to do a rewrite. Kris, the application is slow as a dog. Performance is just terrible. We can't have that. The code is butt ugly. Programming conventions weren't enforced. Like, Gabe named things totally different to how Purnima did. We really need to sort all that out. It's just all over the place. Of course we'll get it right this time. We're so much smarter now. If we'd really known the problem space properly the first time, we never would have done it the way that we did before. We picked the wrong platform. Like, why in the world did they pick Java or Ruby or PHP or whatever is today's designated language whipping boy, Obviously, we should have done it in Go or Haskell or whatever is today's really cool, hip, resume-driven development language of choice. These reasons are all bad reasons for a total rewrite. We know that. People in our industry have been saying this for literally decades. Joel Spolsky wrote probably the most famous blog post on the subject in 2000 called Things You Should Never Do, Part 1. I looked, I don't think he ever did write a Part 2. But he says, the idea that new code is better than old code is patently absurd. Old code has been used. It's been tested. Lots of bugs have been found and they've been fixed. There's nothing wrong with it. Your business rules have been tested and refined. When you throw out old code, you throw out all of that collected knowledge. Not to mention the fact that we all know that rewrites always take longer than you think, probably as long as it did to write it in the first place. So if you're in a commercial product, your existing users are going to get really annoyed when you stop fixing and adding features to the old one while you're working on the new one. So when you're focusing on your rewrite, all you're doing is really giving your competitors a massive gift. You are giving away your market leadership. Now, that's not to say there are never reasons to do a rewrite. There are a few reasons where it is legitimately justified to do a rewrite. Maybe you don't have very many users. Maybe the application is trivial, it was a prototype or if it was a proof of concept. Maybe there are legal reasons you can't run the old code anymore. That's a very good reason to do a rewrite. If you honestly cannot hire anyone to work on the old stack, you may want to think about a rewrite. If testing and deployment are really hard to automate due to the complexity and interdependence of the code base, that can be a good reason. And the other one is if the industry is undergoing a massive shift, like the rise of smartphones or when people started getting internet in their homes. Those are reasons for you to do a rewrite. But in a nutshell, Joel says, you should never write code that you have sold, which leaves us to incremental redevelopment, that ship of Theseus. This is how you can make your legacy software last longer rather than chucking it in the bin and starting over. You're going to replace one plank at a time and make it better. And to me, that ability to evolve over time is one of the key characteristics of robust software, of code that's been engineered to last. That doesn't mean it can't change. Mocus, in 60 years, went from punch cards to green screens to desktop PCs. The Voyager software on board the satellites was updated 18 times during the flyby of Jupiter alone. They're updating that stuff all the time. So it doesn't mean it can change. We're going to talk about some other characteristics of robust applications. One of the reasons long-lived software is able to evolve is the principle of the separation of concerns. This is about separating the mechanism from the policy. A lot of these pieces of software that have run for a long time have a core engine and interpreter, which is kept totally separate from the policy, which is the data and rules. And that simplifies maintenance. It allows engineers to work on one part without updating the other. It also means that if there's a failure in one part, it doesn't affect the rest of the application. So a good example of this, some of you may be familiar with, is the Hogan core banking system. This was a mainframe object-oriented system written back in the 80s. It's been used by more than 50 of the world's largest banks. I'm guessing there are banks in Singapore still using this now. There are in Australia. And it is a clear separation of an inner engine that does the work and data structures and tables which change frequently. And so companies customize the software by a huge metadata database that specifies everything from the screen layouts to the application's functions and sequencing. And then the core has thousands of COBOL computation units that carry out actions as directed by that metadata. And they have scripts that manage the execution of the jobs. And there are similar applications used in the insurance industry. Basically, anytime you have constantly changing policies and data information, and you have a core engine that you can keep that doesn't necessarily need to be to change very often. A lot of long-lived software relies on standard languages. We all get dazzled by the latest languages and frameworks, but the argument against using them is similar to the argument about throwing out your old code. You know, mature languages have had more of the bugs worked out. Their features have been refined based on developer feedback. There are going to be more examples and documentation on how to use them effectively, and there are more people you can hire to join the team. So all of that helps set your project up for longer success. Now, this isn't a hard and fast rule. You know, depending on your project, you may be better off with just a couple Scala developers than a whole army of C++. And you may even want a domain-specific language. That may increase productivity for hundreds of people and just need a couple people to maintain it. But in general, choosing a more mature standard language is a safer bet than something bleeding edge. Along with that, long-lived applications tend to minimize their dependencies. This is where I get to invoke left pad. So, you know, 2 years ago, a developer unpublished 200 of his modules from NPM, including an 11-line package that padded out the left-hand side of strings with zeros or spaces. And thousands of projects like Node and Babel relied on it. And when this package was unpublished, thousands of applications fell over during development and deployment. This is not how you build a reliable, robust system. There is absolutely no guarantee that code that someone else has written is correct, works well, or will be available when you need it. This is an easy one. Robust applications tend to have simple, readable code. Hardly any software is maintained for its whole life by the person that wrote it. And so for an application to be maintained, like Mocus, Voyager, decades long, the code needs to be understood by the people who are going to come after you. That doesn't necessarily mean less lines. Sometimes the shorter something is, the less understandable it is. So robust code is concise. It allows human beings to easily comprehend what it's doing. And lastly, all complex software systems will have bugs in them. No matter what you do, it is impossible for you to write a complex software system that is perfect. So how do you build a long-lived application and account for the bugs that are going to crop up? By being fault tolerant and by allowing for fast recovery. And this is a paper from 2005 called Exploring the Acceptability Envelope by Martin Renard, Christian Kedar, and Huai Nguyen. And so they talk about this idea of the acceptability envelope. This is all the parts of your application that are imperfect but acceptable. And they surround the part that has to be perfect, the core in the middle. So they say that rather than trying to make all your code perfect, you should instead aim for that envelope of acceptability wherever you can. They say that we should think less like engineers and more like doctors. Complex software systems, they say in this paper, are like the human body. It's impossible to eradicate all disease in the human body. What you aim for, not perfection, is to think holistically about preserving the function of the system. Overdiagnosis by a doctor can lead you to treatment that makes you worse off, and throwing lots of exceptions and spending all your time trying to anticipate every possible problem that can go wrong in your program can give you a worse outcome than simply allowing the program to execute through the errors gracefully. The key is for you to recognize which parts of your application have to be perfect and which parts are more forgiving of acceptable errors. So they give a couple examples in this paper. They've used the Pine email program and the SurePlayer MPEG decoder. And what they did is they introduced off-by-one errors in each of these programs, and they compiled them in such a way that the code was oblivious to the failure. And then in testing them, they showed that most of these errors don't actually stop you from reading your email or playing the video. It wasn't perfect, but you could still use the software. And so their conclusion in this paper is that as engineers, you should simply leave acceptable errors in the system. Don't waste your time trying to track down every problem and make it perfect. That will eliminate the risks and costs of trying to fix stuff that doesn't need to be perfect and free you up to focus on the critical regions of your application that actually need it. And just one more thing on that. Another approach to fault tolerance is actually quick recovery. I don't know if anybody in this room uses Erlang, but in Erlang, the language, everything is a process, small and isolated, and processes either do what they're supposed to do or they fail. And the Erlang developers realize that if something goes wrong, you should just let it go wrong. Don't try and duct tape it back together. And they call it the let it crash approach. So when a process goes wrong, it automatically terminates. That failure is reported up to any supervisor of processes that were monitoring it. And then they can restart them, take appropriate action. This means with careful design and testing, Erlang systems can hit 6 nines of reliability. That means 30 seconds of downtime a year. And Erlang apps can even be upgraded in place without interrupting customers. The creator of Erlang said a few years back, if Java is write once, run anywhere, Erlang is write once, run forever. So for a system to be long-lived, it needs to handle acceptable errors gracefully and recover from faults quickly. Now, I realized the other day when I was working on this that there is a perfect fictional example of software that lasted way beyond its expected lifespan, beyond the lifespan of all life on Earth, actually, and that was WALL-E. WALL-E is just a little ship of Theseus himself. You know, we see him, he replaces his tread, he replaces his eyepiece unit, and, you know, he practices incremental redevelopment on himself, and that's one of the reasons he's still the last one kicking when all the other ones have failed. So back to my story. So as you recall, it is 2015. I had discovered that my Roald Dahl site was not, in fact, as robust as I had thought. In actuality, was an unmaintainable nightmare of 20 years of legacy spaghetti code. So I'll admit it, I toyed with the idea of just shutting it off and burning it to the ground, of just walking away from the servers, but I couldn't bear the thought of all that hard work, all that content, all the things people had sent me, of it just disappearing. So then I thought about rewriting it in something cool and trendy, you know, like Node.js or maybe one of those cool Ruby static site generators that all the cool kids were using. But the sole developer on the team, which remember was me, was a manager now and not really as great with the hands-on coding and didn't really feel excited about that big learning curve of learning one of those new systems. So I was having coffee in Sydney where I live with my friend John Alsop, who is a really amazing web developer and author. And I was telling him about all this and how frustrated I was, and he went, "Why don't you just use WordPress?" And I went, "But wouldn't that be like cheating?" And he was like, "Look, I give you permission, okay? I'm old school too, but how much time do you really want to spend on this?" So I gave it some thought. I weighed up the pros and cons. I mean, WordPress is widely used. It powers something like 30% of the sites on the internet. It's written in PHP, which was a language that I did have experience with. Has a big developer community with frequent updates and patches. There are plugins and themes that I could leverage. It's got well-documented code and offers hooks for me to write my own custom functionality. But I also knew, of course, that its popularity makes it a giant target that I would need to put in some serious work to secure it. I also knew that the migration effort was going to be considerable. I had 20 years of hand-coded cruft to clean up. And I will confess that part of my hesitation was just ego, you know? I stand in front of groups of developers all the time, and I get a lot more street cred by telling you how I use some bleeding-edge new CMS than I do by saying I used WordPress. And I don't know what perverse part it is in our brains that makes us wary of tools that will make our lives easier or are attractive and easy to use, but we all just need to get over that, okay? So after talking with John, I got over it, and I decided to use the WordPress. So the migration project took me about 6 months to initial release. I, of course, read everything I could find on WordPress security. I made sure that I was putting good practices into place from the start. I kept all my third-party dependencies, of course, to a minimum. I made sure the ones I used were well-tested, being actively developed. When I needed custom functionality, I wrote my own stuff. I kept my functions as simple and minimal as possible and sandboxed them so that I could still automatically apply core updates and security patches. Now, the bulk of the work was, of course, really just in cleaning up the content, so I recorded every single page from the old site in a Google spreadsheet, and once it was verified on the new site, I marked it as done. And the real advantage for this is I was going to need this for setting up my, my redirects down the track, but it also allowed me to track my progress on the project. 1,488 individual URLs, all written by hand, all given a target on the new site. So I set up 301 redirects for all of these, which meant that all of those inbound links from 20 years would have a new home on the new site. And then it was really just about changing my DNS and putting the new site up. So since then, I've continued to work and improve on it. I've added loads of new content, mostly because, hey, that admin area is actually nice and pleasant to use. Who would have thought that that would make a difference? I commissioned a set of custom artwork from an Illustrator friend and then used that to create a new responsive theme. So, hey, people can use this on their mobiles and it doesn't suck. I use Cloudflare to set up SSL, to act as a caching layer, you know, important for both performance and SEO nowadays. Lately, I've been working on a replacement, building a new trivia system and making it, of course, GDPR compliant. And this is the end result. You know, after 22 years, this site is still going. No, the code underneath isn't the same. It's evolved. It's like the ship of Theseus. But the content is all still there, and every single URL from the old site resolves. And for me, on the web, that's really the important thing. You know, that's what counts. The kids, the visitors who come, they don't care what's happening under the hood. So thousands of people have visited this site over the years, and the framework and practices I've put in place should guarantee that thousands more can come in the years to come. Now, of course, I'm talking here about a site for children's author, you know, not a complex banking application. I'm sure you guys are here because you're professionals. So I thought I'd finish off by talking about best practices you can use in your job with your engineering teams on the code you're writing professionally. How can you build software with a lifespan counted in decades rather than months? Applications that will outlive the latest JavaScript framework. Applications that are more like Wall-E and Voyager and Mocus. Firstly, goes without saying, you should have agreed coding standards and conventions that everybody on the team adheres to, as well as frequent design and code reviews for all your code. This is going to improve readability, it's going to make maintenance easier, both of which are going to extend the life of your application. And what's even better is to enforce your standards by means of static analysis tools. So before I joined Yao Conference, I worked at a startup in Australia called Canva. And at Canva, we used ESLint to flag programming errors, bugs, stylistic errors. This meant that the code that didn't meet our standards couldn't get checked in. We also used Google's Closure compiler to optimize our JavaScript to be faster and smaller, check syntax, and also perform type checking. So if you've heard my boss, Dave Thomas from Yao talk, he says that type checking is the single best tool you have for finding errors in your code at compile time. Now, most modern IDEs like Eclipse, IntelliJ, Visual Studio, they'll allow you to plug in linters and static analysis tools to flag issues and prove that, and actually you can prove that your program's behavior matches its specification. That's really cool, and it's actually super important for anything mission safety critical systems like medical, nuclear, aviation. You should be doing this. Now, a lot of what I'm talking about here comes under the umbrella of defensive programming. That means designing software in such a way it still works under unforeseen circumstances. The idea is that your application has a comfort zone. It has a range of inputs that it's been tested against and it's been known to work correctly. And bugs are what happens when an input takes your application out of that comfort zone. And this is very dangerous for those of us who build systems that work online, because we have to process arbitrary inputs from potentially untrusted sources who, you know, whether through ignorance or malice, are actually trying to induce these bugs. So your goal with defensive programming is to make that comfort zone as large as you can. And there's another paper, I learned about this from a paper in 2007, again by Martin Renard. And this one is interesting. He introduced the concept of input rectifiers. He talks about the Pine, again, the Pine text-based email client. It had a string overflow vulnerability. Basically, if you sent it a message with a carefully crafted from line, it would cause this email reader to crash. And so he developed a tool to force messages into a specific constrained form to keep them within the application's comfort zone. You know, he truncated fields and parameters to certain lengths, he checked them against regular expressions, he removed questionable characters, and this made the application more robust. It removed security vulnerability at just the small cost of a small amount of information loss. And the idea is again, you can't trust user input. And with defensive programming, you never trust user input because you know eventually, inevitably, you're going to receive something you didn't anticipate. Maybe it's just the march of time. You know, if your app lives long enough, you're going to need to handle future inputs that you probably didn't plan on. That can be why one technique is to use whitelists rather than blacklists. You know, if your app, for example, accepts image formats, rather than check and try and blacklist every one that you want to reject, just list the ones that you know you can accept. You can also use assertions throughout your code during development testing to check that your expected input values are correct and they're within the ranges that you expect. And if you want to take this to the max, you use property-based testing. Have any of you heard of property-based testing? Yeah? This is a fantastic technique. It allows you to quickly, easily, cheaply generate tens of thousands of random test inputs. It'll increase your test coverage. It'll allow you to find really rare corner cases you never would have found through normal example-based unit testing. So I found examples where an engineer called Joe Norton at Lambda Jam 2013, he ran a quick check suite of just under 600 lines over Google's LevelDB, and he found a sequence of 17 steps and then another one of 33 steps that would actually corrupt the database with a ghost key. What human being would have come up with a scenario of 33 steps to do this? Thomas Arts, the CTO at Quivik, who make QuickCheck, they in 2016 used QuickCheck to run tests on Project FIFO, an open source cloud project. With 460 lines of QuickCheck tests running over 60,000 lines of production code, they found 25 bugs, including timing errors, race conditions, type errors, and more. That is a very low amount of code to find a very high number of errors. Property-based testing isn't easy, though. It forces you to think very hard about your code. I've seen it described as like being learning to play a musical instrument or get really good at a sport. It's a practiced skill. So even if you've been writing property-based tests for a few years, you can probably still find ways to improve and get more out of them. My friend Jessica Kerr, this is a quote she had, and she's written some really great blog posts on the topic, so you should look up Jessitron if you want to learn more about it. But she says it's high investment, but it's also really high reward. And then, of course, once you do find those edge cases, you have to decide what to do with them. You need to keep in mind that acceptability envelope. Like, is this an important failure that needs to be handled? Or is this something that can be gracefully ignored and still allow the program to execute? If you want your software to be robust, you need to focus your engineering efforts on finding and repairing the important errors and spend less time chasing down the little ones. The campsite rule. This is one of my favorite axioms, not just for programming, but for life in general. And it is, try and leave this world a little better than you found it. It was popularized by Robert Martin in clean coding as the Boy Scout rule. I prefer calling it the more inclusive campsite rule. And the idea is that scouts always leave a campsite cleaner than they found it. They're supposed to. So imagine if you took that approach with your code, that every time you checked out a module of your team's code, you made it a little bit better before you checked it back in. You have to make it perfect. You just have to improve something. Maybe you renamed a variable to be something more descriptive, or you split a really long function into two. Imagine if everybody in your team did this. Instead of just sitting there, your code would be constantly getting better. This is just, continuous improvement, really quite literally. It would mean that your mindset changes from just caring for your code to caring for your team's code. It can be a really, really powerful mindset. And lastly, it's important that you provide good documentation, not just how the code works, but why you made the decisions that you made. Do not wind up like me, looking at your own 20-year-old code and wondering why in the hell you did that thing that you did. There was probably a good reason at the time. If your program is used for any significant length of time, there are going to be people who come after you, and they're going to be just as mystified as you were. So you need to record that stuff. And as a side note, wherever possible and legal, I urge you to document your own projects that you've worked on for your own future reference. Sometimes the success of an application is out of our control, and it is a shame, my friends, to look back on your career and realize that most of the work has just disappeared. I actually had to grab most of the screenshots of my own site from archive.org because I did not do a good job of saving that stuff. So learn from me, save your stuff, document it. And that is the story of my 22-year-old website, which resulted in me getting as close to my hero as possible to get. This is the Gypsy Caravan at his house in England. That in the upper right is Wally Saunders, who sadly passed away a few years ago, but he was the inspiration for the BFG. Look at those ears. Plus also, I was taller than the BFG. How weird was that? And that was in his riding hut. And it literally gave me a career that's taken me around the world. Now, in the 2 decades since I built this site, I have worked on a lot of applications, a lot of websites, and most of them are gone. I'm sure if you are over 30 in this industry, your story is the same. A lot of what we build feels ephemeral and it can feel really hard to feel like a craftsperson if everything you build disappears. And I love the idea that this one thing is still around. So I hope today I've shown you the value of preserving your legacy applications rather than just always immediately jumping to throwing them out and rewriting. You can make useful applications that last a really long time by insisting on separation of concerns, by using standard languages, by minimizing your dependencies, by writing simple code, and by being fault tolerant. And I've given you some ideas of best practices that you can use, like enforcing coding standards, of using static analysis tools, defensive programming techniques. If you take nothing else away, go look up property-based testing, please, promise me that. And always leaving the code base better for the next developer, which may actually end up being you. Your applications may not visit interstellar space or power the backbone of the financial industry, but they can be really useful and valuable to your customers for a lot longer than you think they can. Thank you for listening. I'm happy to take questions if anybody has them. Yes?
For the best practices and the documentation, can you elaborate further? I think my voice is loud enough for this room. Because, when we go for Agile, the documentation is a bit of a question mark when we go with the Agile practice. So, can you elaborate something further? What type of documentation do you recommend for these best practices here?
I mean, by documentation there, I'm talking about a really wide range of stuff. I often, think about how many times you go to GitHub and you find something that looks useful and it hasn't been touched in 2 years and you don't know if it worked, if it didn't work. We often, I think, need to get just as good about documenting the things that work as documenting the things that don't work. So, yes, document your code, whatever you're doing for your documentation of your code, do more of it, but also think about what you're not documenting. Think about documenting the decisions that were made and why that they were made. And think about documenting things that you've tried and don't work, especially if you're putting that out for other developers. I just think that we're often not very good at that, and that can be very problematic for the people who are coming after you and trying to maintain. I'm trying to revive a piece of software that's a Java software that's several years old, and the person who left it, I don't know why they left it. I don't know what the current state of things, what the existing bugs were. So just be better at that sort of stuff. But no, I don't have any good solution for how you work documentation and make it a priority into, fast-moving agile teams. We'll talk afterwards. Was there someone up in the front? I'm going to be around all day. Come talk to me if you like. Oh, is there someone back there? I saw someone in the back. Yeah.
So if you say property-based testing and you compare it to all the other kinds of tests you could write, unit tests, integration tests, EV tests, which you usually have a bit of a different approach when you write them and how you write them, how would you weigh off?
It's not a replacement. It's another arrow for your quiver. It's another tool for you to use. So it's not intended to replace the other types of testing you're doing. Other types of testing have their own benefits. It's just one that we've had several speakers on at YOW, and it's a new technique that we're not seeing enough people making use of. So if you haven't looked into it, highly recommend it. It's a good one to learn and to have in your arsenal. Yes?
By following all these best practices, right, we come up with the cost of resources and cost of time. But now in a trend where the requirements are changing very frequently. Let's say yesterday's requirement may not be applicable today. So how does it really benefitable by following the spending so much of this much best practice?
I mean, if you need to look, I did in the previous version of this talk, I had a couple slides in there from, I think Mark Zuckerberg, when he came out on stage and he said, Facebook's all about moving fast and breaking things. And that gave a lot of people this idea that, yeah, we can just write crap code and throw it out there and stick it at the wall and see what works, and cool. And the fact of the matter is, he actually walked back from that a year later, and he put up a big slide that said, move fast with stable infrastructure. And that's not as sexy. That doesn't get written up in blog posts and selling books, you know. So there is a business case to be made for it. And I think if you're in, because I've worked in startups that are all like, oh, we don't have time for that. We gotta move quickly. Well, actually, Zuckerberg walked back from it. You know, there is a business case to be made for preserving the value of the code that we have. So I don't have any tricks for how you make that business case, but yeah, I think a lot of people bought into that sort of move fast startup mentality. And the fact is, you don't have to not move. We're not saying you can't move fast. You move fast with stable infrastructure, with not checking everything out all the time. All right, I'm going to be available afterwards. Thank you very much, everyone.